pleasure to be part of the History of Ideas seminar. I think it's one of the very important activities which allows us to reflect upon very important movements and ideas across various disciplines in order to try and understand the complexity of how some of these ideas have developed, and in doing so also to reflect upon the state of our own knowledge now and the way we respond to what we think we know about things. I thought of talking about space because space is one of the most difficult ideas to understand. It's also one of the most primal things. It is something which we take for granted in a very fundamental sense. But the moment we try to think about it, we seem to run into many kinds of problems. I would actually have liked to answer the question of what is space, but I would not be doing justice to the History of Ideas seminar, which is to trace the trajectory of how people have thought about space, of how one conceives space, and how that was related to many of the scientific and the cultural and the philosophical systems which prevailed in very many different traditions, different countries and civilizations. The basic questions in this are very simple. Is there something called space? And that is actually the motivation for my using the title, What is Space? Because if you look at the history of space, through geography, you would find that what seems to be the basic question is there something called space? So using that as an image, I want to construct the history of it. Because the question in itself is very simple to ask, but very difficult to answer for the following reasons. Our ideas of existence, when you say, what is a chair? We seem to have a pretty good idea of how to talk about what is a chair. I say that there is a chair in front of me, it is concrete, I kick it, I feel a pain. The famous Berkeley's example of Samuel Johnson's example to show something exists. We seem to have certain criteria for saying something is there. Maybe this table, this chair, or the glass of water, and so on. How would I then approach the question of asking, does space exist? Is space there like the chairs are here? Now obviously, the question itself may actually may not be framed correctly, for the simple reason that to be something, to be a chair, to be any real thing, is somehow to be in space. That seems to be a very fundamental aspect of existence, what people would call as a spatio-temporal character of existence. That is, to be a chair, it has to occupy space. If there is no chair and if there is nothing, then it's very difficult for you to say that something exists. So this criteria is obviously not applicable to space. You cannot ask the question, is space in space? We would have to have a grasp of asking such a question. Is there something, is space, does it belong to space itself? The character of space which we commonly accept, which we use in our daily talk, is that there is space around me in this hall. There are objects, there are people, there are things in this room, but along with all this, there also seems to be something called space, what we call as space. It could be that what we call as space is just that in which no other object is there. If you fill the top, let's assume that this is our open space around us, if you fill it with some material, clay or chairs or tables or whatever, you would not say that there is space around the room. So in some sense we make a commitment to saying that there is something around us, but it's very difficult to get a grasp on what it is that I say is around us. And philosophically this has been the basic question. And to set the tone for the basic philosophical discussion and the historical discussion is just this. Should we say that there is something called space around us, or should we say that space is nothing but relationships between objects? That all that there is in the world are just objects, chairs, me, you, tables and everything, and all that we call as space is a relation between two material objects. That is in the history has always been called as the relationist view of space. So our basic ideas of space seem to imply that there is something called space, which is absolutely penetrable. In other words, if there is space around me, I can walk through space in some sense. If you say that there is some space around me, I can walk from a point to the other. Any object can penetrate through this idea of space around us. And fundamentally, and more importantly, it allows for the possibility of motion. Because if you ask a simple question, is motion possible without space? Which, in fact, if you look at it, if you look at the history of space right from the beginning to the present days with modern scientific theories, this idea of trying to understand what motion is seems to be very central. How is it possible for things to move? And if things can move from one place to another, does it imply that there is something called space in which it moves? So the idea of the possibility of motion seems to imply the existence of something called space. Space also gives identity to objects. If, for example, there is no space between the chairs, that there is no detectable space between them, would we say that there is space between objects? If you do not identify the boundaries of objects, can we then say that that is an object? And if boundaries of objects are given by the fact that two objects are separated from each other, then does that imply an existence, necessary existence of space, which makes objects possible, which makes us realize that these are objects? There is also the question of the quality of space. Does space have any quality? Typically, when we talk about space as if it's infinite in distance. I mean, it goes on and on. There is no limit to space. There is no point where you can go to and then say, this is where space stops. Because you stand there and look out, what do you see? This has been the standard argument against the limitations of space. You go to the boundary of space, then what is there beyond it? So we presume in our common understanding of space, it's infinite in expansion, it is homogeneous, it doesn't stop your motion, you want to fly up, you can continue to fly up, and so on. The causal influence. Does space, can it have any influence on us? Does space have any kind of causal influence on objects within it? Objects which are situated within it. The other question is, the very important question is parts and wholes. If you take a chair, it's got parts. The leg is a part of it, the hand is a part, what you sit on is a part of it. Does space have parts? In other words, if I say this is space around me, can I just take this space from here, which should be a part of it, and then take it out and say, oh, this is the space from that room? Is it possible to even think of what parts of space could be? And finally, the question of existence. Is there something called space? Is it only relational, as I told you? And for example, the other very important question of its existence is, suppose this was a room filled with wood, and you dug up all the wood and you have created this room. It's a hole. You create a hole in a room. So what have we done when we create a hole? Have we created space? So is hole, what you call as a hole, is it just space? Or when we have removed the matter from this room, have we filled in space and removed matter? I mean, these are, of course, problems which worry philosophers. That's their job. But it's my job here to communicate to you that these kind of questions make some sense. It's very important to ask these questions. So what I want to do is, when I thought about it and I said, how am I going to talk about history of space? Every civilization has had a historical growth in the idea of space. Space has all these conceptual problems, fundamental questions about it. So how am I going to integrate all of them together? And my short introduction to the various problems of space is just to indicate how I'm going to do it. I'm going to look at some of these basic ideas which occur in different traditions. So we have a simple example of how the idea of space has been understood in all these cultures. Let me begin with the meaning of the word space. Space itself is derived from the Latin spatium, basically, which means lie open. The idea of being open, being infinite, being absolutely free allowing motion, is something which repeatedly occurs in all conceptions of space. The Greek tradition, well, they've had different concepts of space which I'll talk about. The word which Plato uses is kora. Again, basically indicating emptiness, free space, vacuity. And many times when we talk about space, you see that it's been translated as ether. So that's another term which repeatedly comes along. In the Indian tradition, as many of you must be aware, the word for it is akasha. Now, there are subtleties in the use of the word akasha, which I will discuss when I talk about certain Indian philosophical systems. Basically, akasha means that which lets things manifest themselves. Again, it has very similar connotations of open, to be free, vacuity, ether, and it also has this connotation of, it translates as that which makes things manifest themselves. And here we have the common thread, which is without space, it's not possible for objects to be there. It is in some sense, we'll have to clarify in what sense, space makes things be what they are, come to presence, be perceivable as we see them. And that's because of this particular character of space, the existence of space. Space has also been very closely tied in with theological concerns. I'll talk about it when I come to Newton, but I just want to make a point here, which is that one of the names of God in Judaism is Makom, which is actually space. In the Indian context, and this is a very significant difference from the Western ideas of space, space is the beginning. If you look at the Rigvedic creation myth of the golden egg, which is there in this billowing fluids, tossed about, turbulent, and then leads to the creation of the heaven and the earth. The creation of the heaven and the earth and the space between the heaven and the earth is the notion of space in the Rig Veda, and that is called Antariksha. It is this space which is between the heaven and the earth, and the idea of space here is that it is bounded. It is not the kind of infinite space that we talked about earlier. It's a finite space which is bounded by heaven and the earth. It's very interesting, again, in the Indian tradition, that God is seen as the architect, and many of the important representations of space in Indian thought have been through architecture. It is the creation of things, creation of space, creation of elements with a particular geometry, with a particular relationship with each other, which catches the spatial element. So, if you want to compare traditions, if in the Hebrew tradition the beginning was the act, and in the Christian tradition the beginning was the word, in the Indian tradition the beginning was space. And this, according to historians, has played a very important role in the development of the idea of space. Because space as infinite, extended, in which things lie, was the beginning, was the conception which you began with. Whereas in the Western tradition, which I will list out very soon, you will see that it was very different. From the Vedic period, if you look at the Upanishadic period, the word Akasha essentially arises from that time. It doesn't occur in the Rig Vedas. Akasha again here is seen as one of the 5 elements, like earth, wind, air, fire, which is shares with all the other, even the Greek tradition. Akasha is the 5th element. It's a subtle element, and it is infinite. It is free, it's open space. As I said, sometimes it's been translated as vacuum and ether and so on. Now, what is very interesting about this conception of Akasha, which again has a resonance in almost all the philosophical systems, is that this space can be perceived sensorially. And that's a very profound, of profound importance. That is, when we ask, is there space? If I look at and ask, do I know if there is water? I drink it, I have a sensation about it. I touch the chair, I have a sensory experience of the objects. But I go around, I smell, I can't smell space, I can't touch space, I can't eat space, I can't taste it. But according to this conception of Akasha, there is a sensory experience of space. And that sensory experience of space is perceived by hearing. So sound makes space manifest. Sound is a quality of space. And when the Nyayas take it up, they take it up from sound to music as the essential characteristic of space, a very essential quality of space. Again, in the Indian concepts, Akasha harbors time. The notion of time and space being independent is not given in that. Regarding the question of the existence of space, would you say that this is just a concept, or would you say that there is something called space? Again, in the Upanishads, the commitment is to what we call in philosophy is ontological commitment. That is, you make a commitment that there is space. You say that it is there. It is a substance where we shouldn't confuse substance as matter of this kind. It is a substance, and it is in fact in the hierarchy of things the closest to Brahman. So Akasha plays a very important existence role within Indian thought. And if you look at the Chandogya Upanishad, for example, there is a very well-known statement which says that all arises out of Akasha and all goes back to Akasha. Akasha is all that there is. Which is, Akasha is the name of the possibility of coming into existence of the perceptible world. In other words, without the existence of Akasha, you cannot have the world as we see around us. There is another very important element in the Chandogya Upanishad which is, I think, very useful to delineate between the Indian and Western traditions, which is that in the picture of the human being, there is a space. Within the picture of the human being, there is a lotus. Within the lotus is a very small space. It's called the Hridaya Akasha. And what is interesting about it, about this story or narrative, if you like, is that it is so small, it has no measure. But it is exactly equivalent to the whole cosmos around you. And there is a very important interpretation one can make here, and I think one should make here, which is that the quality of space is not extension. It is not necessary for space to be infinite in the way we understand spatial extension, but it is that all the qualities of the larger cosmos are there in this Hridaya Akasha, which is very small and of no measure, but everything else is the same. And repeatedly, if you look at the meditation techniques, etc., it's always to reach a state in which complete awareness comes when you rest in that Hridaya Akasha. Now, what does this say? This says two very important things to distinguish space in different traditions. One is that there is a quality to space. There is a sensory possibility of knowing that there is space around you. In other words, space is accessible to our senses, just like the chair and the table and chlorine gases. And another very important part which distinguishes it from other Western traditions is that a notion of inner and outer space. The distinction between an idea of inner space and an idea of outer space, which is something which you would rarely find in the Western tradition. And what is this Western tradition? If you look at the Greek tradition, the pre-Socratic, the basic problem which they grappled with was that of change and appearance, which has stayed on through the history of Western thought. What is change? How can something be permanent if it changes? This is the most important question for the pre-Socratic. And many of you are aware of the Zeno's paradox, which is essentially a question coming from the pre-Socratic tradition, Zeno of Elea, who asked this question, how is motion possible? And the paradox, which many of you may be aware, is actually very simple. If I am going to move from here to there, I first have to move from here to halfway. And if I have to move from here to halfway first, I have to move from here to quarter this distance. And if I have to go from here to quarter the distance, I have to go from here to 1/8, and so on. That infinite progression to him actually proves that it's impossible for objects to move, that motion is impossible. And again, why were they so obsessed with motion? Because they did not know how to characterize change. If I move from here to here, have I changed? That's the basic question. What changes? What has happened when I move from a point to the other? Now, as I said, this is played one of the very important roles, including various Zeno's paradoxes. He gave more than one paradox in the development of Western thought. And since I finally will tie in with the developments in modern physics, we have to realize that much of the tradition of what we have inherited today in modern physics comes from many of these questions. Plato was another very important figure after the pre-Socratic. Plato had a very interesting conception of space. He actually gives about 8 metaphors for space. And among the metaphors are the image of a mother. Basically, his image of space is a receptacle, it's a container. It holds things within itself. It allows for objects to be placed within it. And he has a very interesting term for it. One of the metaphors is nurse of becoming. Space is a nurse of becoming. Space nurses objects within it, allows you to have all the objects of the world within it. But for Plato, because of the Greek cosmological view, there was nothing called empty space. You could not have empty space, which means space without objects in it. And this again has been a very important theme within the Western theories of space. Is it possible to have empty space without matter? If you believe in the relationist theory, like I told you, that space is what we call as the relationship between objects, then it means that there cannot be empty space, because without objects there's nothing called space, because there's no relation between objects. So for Plato, the Greek cosmos was a sphere rotating, and therefore for him space had to be finite. There is a place beyond which there is no space. And to anticipate the question of, if you go to the boundary and look out what is there, he would say that there is no place for which objects can exist outside that. But here we already see a very different conception of space, not as the one we take for granted, which is infinite and extended completely, but as something which is bounded, bounded by the sphere. It has no qualities, it is homogeneous, it's spherical, and it's everlasting and indestructible. It's immutable, nothing changes. You cannot destroy space. You can take an object and break it up and do whatever you want, but in space you cannot destroy space. And this again a common theme which will run through most of the traditions you will see. The next important figure in the Greek tradition was Aristotle. So Aristotle's conception of space is very interesting. He thought of space, he uses the word place to repeatedly refer to space. He doesn't talk of space as such. Although the same ideas of Plato resonate in him, that space is finite, space is not infinite, that there is no possibility of empty space. But given his structure of how he conceived of the world, how he picturized the world, and you remember that he is the one, in the sense, the father of physics. Much of his work on space, he doesn't talk about space and time, but it's largely in his book called Physics. His idea of space is very simple. His idea of space is that there are places. Objects occupy places. So when I stand here, I occupy this place. And when I stand there, I occupy another place. So space is nothing but the sum of all the places which objects occupy. But then that makes it very confusing. So what he wants to do is, he says, if I occupy a place, what is the relationship between me occupying the place and the space around me? Aristotle's answer is that space is that which contains me, which is that boundary around me. If you imagine that I'm wearing a sheath around me as I stand here, just that boundary, the surface boundary around me is what excuse me, he calls as place. And the sum of all the place is to him the totality of space. And if you do look at the idea of place, it's very clear, it's a very commonsensical idea. Objects can occupy place, but places themselves don't move. I can go from here, I can go there. It is very, objects can occupy any place you want. And the other very important idea of Aristotle, and Aristotle, I must mention here, has been the most dominant influence. Depending on positive or negative, depends on which way you look at it. A lot of people think that scientific Western science as we know now was inhibited for centuries because of his ideas of motion and space. Because one of his central ideas was that things move to natural place. That all things, all elements actually, have their own natural place. Because you remember that we don't have a conception of a force which tells you I move from here, or if I push a body it moves there. So he had this, his basic idea was that elements have a natural place to which they move. So motion is explained by saying that things are moving to their natural place. Imagine going to a house in a sense. Every element has its own house to which it's going. All motion are things which are going to their natural places. Well, for example, of natural place would be fire always goes up, air goes up, whereas earth and water would go down. So Aristotle's conception was made space finite because his picture of the universe was also a three-sphere. The earth was a sphere, the sublunar realm, and the heavens, which was the final sphere, where the fixed stars were there. And the heavens was made of ether, the fifth element, non-destructible. And in fact, the word quintessence, the fifth essence, comes from that. So for Aristotle, then the space is finite. You cannot go beyond that space. It is also not isotropic. In other words, that it has preferred directions. Not all directions are same. And because of which, there is no impossibility of vacuum of his picture. Very similar to Plato. And the point that things, the motion is explained as moving to natural places, in fact impeded a lot of development of thought on mechanics and motion. So the very interesting point here is that for Aristotle, space is a cause for motion, which is something which we don't will not accept now, which is that space causes things to move, the efficient cause for Aristotle. As I said, Aristotle's influence should not be underestimated in the development of science and philosophy of space and time. What I want to do now is contrast it of this particular period on the development of the idea of space in Plato and Aristotle with some of the Indian philosophical systems, mainly because, again, to point out some essential differences in the way different traditions had conceptualized space. The early Buddhist school, the Theravada Buddhism, Akasha, again, this is a very common term in all Indian philosophical systems. It was not a reality, but it was a concept. And that's a very fundamental disjunction from what we have seen earlier about the ontological, the existence status of space. Interestingly, for the Buddhists, this Theravada Buddhism, Akasha was a potentiality and it was a limitation of matter. There are resonances with Aristotelian thought here. That is, it is space limits the extension of matter. It's the other way of saying is that there are two objects are different because there is space between them, is to introduce the idea of limitations, to say space limits the extension of objects. It's not that space is pressurizing objects into having their boundaries, but it's a notion of limitation which allows between objects, which is the basic function of space. They do not subscribe to Akasha as either ether or matter. It's pure void. And like the other traditions that are common to Indian thought, which I think is very important, is this distinction between inner and outer space. In their formulation, of course, inner space was with respect to the body, and the outer space was, the inner body and the outer body. And again, in resonance with a very important character of space, space is the possibility of being occupied. That is, space is what allows occupation to be possible. Otherwise, there would be no objects, there would be no distribution of objects as we see that. A difference among the various schools, there's a lot of commonality, and I'm giving you a very brief history of this. But distinct difference among two Indian philosophical schools in the 10th century AD, that particular period of time, would be the Jainas and the Nyaya school, which had a very interesting but different conceptualization of space. Again, this is of very central relevance to how the traditions differ in the way they understood space. For the Jainas, there were two kinds of spaces. Once again, different kinds of spaces is something very specific to Indian tradition. The two different kinds of spaces would be loka akasha, the space of the physical world, which is nothing but all the objects plus the space between them, what we normally call a space between them. So this room, the whole world with the space and the objects would be the space of the world. And then aloka akasha, which is the infinite space outside it. So it is, again, I try and point out what the basic philosophical significance of this would be and why it is a very interesting idea for here. For the Jainas, another very interesting idea was that to consider space as being made up of atoms, in some sense spatial atoms, what we call a spatial point. It is like Akash Anu. You have all these points, atoms of space, which make up space. And then they had a very fundamental philosophical problem. They said, if there are all these atoms, what stops them from moving? Because all these atoms should be flying away from each other, and then you would never have an object because things don't come together. There'll be no coherence. So for that they had two principles. I mentioned this because again this is an idea which resonates both in the West and the East in different forms. One is the principle of rest. I don't want to make a jump and call this a principle of inertia, but it's a principle of rest, which is that it is not a force, and it's called, the word for it is dharma. It is not a force, it is just a principle that objects will be at rest. But then if all these atoms are at rest, how is motion possible? Nothing can move. Then they have another principle, the adharma, which is to say principle of motion. But neither of these are causal things. Causal means they do not cause all these points to stay, or they do not cause these points to move. What causes are forces and other things which we see in the physical world. The Nyaya school, let's say from 1200 to 1800, also had a very important distinction to make, which was that they broke up the idea of Akasha into ether and Akasha, which is they had both connotations for it. Ether is the one, remember that the common theme is that space is sensible, sensorially accessible. That the quality of sound, listening to music is actually in some sense being in touch with space. So when they broke up this concept of ether and Akasha, ether was what carried sound and space was a quality-less thing. But as many commentators have said, the distinction between these two has not been very carefully carried out by them. For the Nyaya, it is space which gives rise in us to ideas of distance. How do we have ideas of saying, this is near to me, that's far to me? So it is the existence of space which generates in us the very simple idea of distance. Very simple psychological notions of saying something is near, something is far. And as you can see, why the existence of space is so important to them. Space has to be inferred for the Nyaya. And it is basically the cause for existence. It is what makes existence possible. Again, a common theme between all these different traditions. And just as a final point to connect to the Indian tradition, again to point out some very interesting differences between that, is the Yoga Vasishthas. Now there you have three kinds of space. The physical space, the mental space, and the space of consciousness. And to them, the space of consciousness was of prime importance. It is the main, the one and only reality for these people. And what is interesting here is that in this conception of space was always superior to time. And there's a story of a person, Akasaja, the son of pure space, who doesn't die, and time is very annoyed about it because this chap is not dying. So time goes and tries to make him die, and he doesn't die. And the moral of the story apparently is that it is pure space which is indestructible and which is superior to time, because time is involved with the idea of karma and death. So the pure space was seen to be the ultimate ontological reality for them. Okay, in all this very brief examples are just to illustrate these points, which is that the idea that different kinds of spaces which exist, and the idea of inner and outer space, which again is something which you would rarely find in the other traditions, and the idea that space has qualities of certain kinds, sensorially accessible, etc., has been a very important, not just in the Indian philosophical system, but also in its manifestation in its architecture, for example. Almost the people who have been working with temple architecture, etc., have done work to show how these ideas of space are represented within the building of the temple, etc., etc. So this is a good background to have when we contrast with how the idea of space developed in the West after Aristotle. Because after Aristotle, Plato was a very fertile time for Greek philosophy. After Aristotle, there was a very good school in mathematics, which included Euclid and Archimedes. But after that, the Greek civilization, in terms of its development in philosophy and mathematics, dropped badly. And again, I'm giving you a very brief history about it, but just to indicate the kind of influence which happened during that time. The Romans came into prominence, and it's very interesting, one of the historians comment that the Romans are very interested in building roads and houses and so on, and they're not interested in these kind of Greek thought. So there was a general decline in, in the propagation of Aristotelian or Platonic ideas. And it only revived in the 12th century. So we're really talking about a large period for 1,000 years in which a lot of things happened. The rise of the Roman Empire, the breakup of the Roman Empire into the East and the West, and invasions of Huns and the German tribals and so on. It's only in the 12th century in Europe that there was a revivalism of Aristotelian ideas. And the 12th century revivalism was due to the Arabic scholars, who translated and who also value added to their own works on Aristotle, and then popularized it in Europe. And the next revival for Aristotle, along with this, was in the 15th century, the Italian Renaissance. And how the Italian Renaissance came about is also very interesting, which is after Constantinople fell to the Turks in 1453, the Greek immigrants went to Italy. And the Greek immigrants went to Italy with all their books of Aristotle, Plato, Euclid, and so on. And in fact, they went and propagated the Aristotelian ideas in Italy. And the first, the Plato Academy in Italy was about 20 years later, about 1472. So it was this influence which really catalyzed Italian Renaissance in the redevelopment, rethinking of Aristotelian ideas and the Greek ideas with respect to space and time, but with respect to a lot of other philosophical questions too. But in spite of all this, the prevailing view of Aristotle, of his idea of motion, natural motion, finite space, space as being anisotropic, etc., prevailed till the 16th century. And in the 16th century, there are a series of events, again, the lead taken by the Italian natural philosophers, as they were called, which really brought down Aristotelian ideas. So when we are very comfortable with what we believe are the correct views of the world today, this is a very interesting retrospective lesson, which is that it took over 16, 17, 1800 years for ideas which today to us seems obviously wrong to be overthrown. And for Aristotle's ideas on space and motion to be overthrown, there are, as I said, very many reasons. One of the reasons, where there are two very well-known Italian philosophers, Bernardo Telesio and Franciscus Patricius. He's a very important philosopher of the Italian natural philosophy school. And they came up with a model of space, which is that space has an independent existence. It doesn't depend on objects. It is there, like we sometimes have a commonsensical view of it. It is the receptor of things in which things are placed. It is homogeneous. And most important, unlike Aristotle, they said there is no natural place to which things go to. Things move not because of space, but because of forces. And that was a tremendous change in the Aristotelian view. Space doesn't cause things to move. It's force which causes things to move. And so this is the 16th century philosophers. By the 17th century, it is clear that space had become the necessary substratum for almost all physics, for all physical processes. It had become established by then in that sense. Now, the Aristotelians' influence was also diminished by very many attacks, other than this formulation of space by Patricius. One was Copernicus. As you know, that his theory that sun is the center immediately demolished a very important tenet of Aristotle, that the earth was at the center of the cosmos. Then Kepler's showing that the planetary motion is not a circle but an ellipse. And to the Greeks, both Plato and Aristotle, the circle was a very important figure. And their formulation, what things move in a circle and so on. So here was this demonstration by Kepler that things did not move, the planets did not move in a circle, they moved in an ellipse. And that's another very important part of Aristotelian idea fell. And Descartes, who was a mathematician, who had his own very funny views on matter and motion, but a very important thing he did was he made motion an analysis of mathematics. And that's very important because it was the first time, as a tradition, that space was seen as a quantity, not as a quality. Repeatedly, as we have seen in various formulations, there was no quantifiability to space. And Descartes' analysis of motion through use of mathematical techniques made the possibility that space is a quantity which can be measured, which you can do various things with. And remember that by that time, the very important point in the development of modern science was Galileo's exhortation to all people, scientists, to mathematize, to express the world in terms of mathematical equations, and to quantify things, not to talk in terms of quality. You cannot do physics if you talk about the shape and taste and color and so on. Talk about things which you can measure, which you can quantify. As I think Maurice Klein had written, if Galileo had anything to say to the modern scientist, it would be that yours not to reason why, yours but to quantify. That was already, so that was about the third attack on Aristotle. And the fourth attack was, this is a kind of thing which you rarely hear in science and philosophical discussions, and it shows the hierarchy of doing and thinking, which was actually the development of the vacuum by Otto von Guericke. He created an artificial vacuum and showed it. If I remember from my school days, they put a two hemisphere and horses were pulling it and they couldn't pull them apart. So it demonstrated the existence of vacuum, which was the final blow to Aristotelian ideas. So all these developments by the 17th century had demolished some of the basic tenets of Aristotle. Again, remember, it took 1500 over years. And this was the time in which Newton came. And if there is anybody who has been influential in our modern conceptualization of what space is, it was Newton. And in Newton formulated his mechanics, he had just four fundamental concepts, which are space and time, mass and force. These were the basic ideas by which he constructed his mechanics. For Newton, space was homogeneous, spread out. It is undifferentiated, which means that just as we accept now, if you say that there is space around me, there is nothing which allows me to say this space here is different from this space here. I am not able to differentiate parts of space if we say that there is something around us. Okay? And for Newton, this was a very important problem because in spite of him being a theorist, he believed very strongly in common sense experiences. He believed that should drive physics. So to him, things which had to be sensorily accessible, something which are, some sense you know that these things are there, it was a very important thing. And if he said there is space and you are saying that I cannot detect this space or that space, it became a very serious problem for him. So he said that because it's indistinguishable, because I do not know how this space looks different from the space outside me, I have to devise ways to be able to differentiate it. And that's the origin of the coordinate system. in the sense that you could have some kind of sensible measure which somehow tells you, not in terms of sight, sound or normal five senses, that this part of space is different from that part of space. And therefore, contrary to our modern understanding of coordinate systems, for Newton these coordinate systems were real. They were something which you would make a commitment to saying that yes, there are these coordinate systems, but it's not very surprising because Newton was a realist about mathematical entities also. Now there is a very important development in Newton which has influenced the growth of physics, which was his idea of absolute space. And this is related to his first law of Newton's motion, which I'm sure many of you are aware, which says that basically that objects continue to remain at rest or at motion, uniform motion, unless they're acted upon by some force. So basically it says that if I'm at rest, I stay at rest. If I'm moving with a constant speed, I stay with a constant speed, unless somebody else is pushing me or whatever, unless some force acts on it. And to Newton this is a very important principle, because this connected to him his fundamental belief that common sense, basic experience should somehow be reflected in science, in his physics. So he thought Newton's first law, which is the law of inertia, that bodies continue to remain at rest, is actually very, very important principle. And actually it is a very important principle. But then if we ask ourselves a very simple question, why should objects which are at rest continue to remain at rest? It's actually not a simple answer. Why would you say that objects that are at rest continue to remain at rest? Or that if they're moving with a motion, then you apply a force for it to change its thing? For the first law of inertia, for Newton to hold good, he knew, obviously there was some idea of relativity in that sense. It's not the relativity which comes out in physics later on, which is that if you are moving with respect to something else, the velocities can be different. It looks different, speeds and so on. So for him, if you say an object stays at rest, then the question is, with respect to what? There has to be something with respect to which the object is at rest. And for Newton, the answer which is again has very interesting overlaps with other traditions, he said that there is something called absolute space. The space which you see of objects, etc., are relative spaces with respect to an absolute space. And what is this absolute space? Again, it reminds you of other traditions, which is that center of space. Mount Meru was mythologically a center of space. Mount Kailasa, some people say they were the same, some people say they are not, which are seen as a center of space. So there is a center to space. And when you say there's a center to space, it's a very interesting comment, which is to say that that center is unmoving. It is the frame with which all motion is possible. So as you see, even after 2000 years, among all traditions, the idea of motion still plays a very fundamental role in our idea of space. And for Newton, when he said there's an absolute space, he was asked to say, where is this absolute space? What is your frame of reference? Where is this absolute point located? And he said that it is located not on bodies, not on earth, moon or sun. He said that, remember his formulation of center of gravity, you have many objects, there is one common point by which they move. So he took the sun, the earth and the planets and said that there is one point in space which is the center of this, which will function as your absolute space, the reference point by which all motions are possible. He of course did not take into account the motion of stars and so on, because in his time stars were seen to be fixed, and it was only after his death that people came up with the theories that stars are also moving and so on. So he came up with this idea of that there is a particular point somewhere in space with respect to which we know which is moving, which is not moving. Absolute motion is possible by referring to that particular center of space in some sense. But the problem with this center of space or the absolute space was that there was no way in which you could do an experimental check. and following his own methodology and increasing view that things should be verifiable. So the question his opponents asked is, how do you show me that there is the center of space? Well, how do you tell me, how do you prove to me that there is absolute space? And his most vocal critic was the famous philosopher Bishop Berkeley, who refused to accept that there could be a concept of absolute space for some very interesting reasons, also very interesting philosophical reason. So Newton thought he could show this by an experiment, and the experiment he did was, this is the rotating pail experiment. He took a tub, filled it with water, a bucket with water, hang it with a string, rotate it so that the string has a rotation, and then leave your hand, it just rotates back. And he looked at that phenomena of what happens and saw that first the water is at rest, then it moves with the pail, and then finally it has this concave, it climbs up the walls of this bucket. And Newton claimed that this proves that there is something called absolute motion. That is the centrifugal force. He thought that rotation of this kind was indicated or proved in some sense the existence of this kind of forces, absolute motion, and therefore you infer the existence of absolute space. And this, of course, was a contentious problem for another 200 years after that, 100 and odd years after that. But by the end of his life, Newton had identified absolute space with the sensorium of Godhead. He had, and this is a very important point for Newton, because right from the 1st to 15th century, space was a very theological idea which had been taken up by various people. Because there is something in common between God and space. Both are extended, they are both infinite, there are no parts of both, there are no destructible parts. I can't remove a part of God from here and put it somewhere else. And in fact, Newton's two very important influences were Henry Moore and his teacher Isaac Barrow. Isaac Barrow was a mathematician, and he wanted to create geometry in consonance with his theological ideas. And he said that the infinity of space, the homogeneity of space, was a reflection of God's omnipresence, just like the infinity of time was a reflection of God's eternity. Newton was very influenced by either of them, both of them, and Henry Moore was the resident spiritualist in that period. And in fact, Newton mentions, when he writes a letter to his friend about the Principia, he hopes his very influential book, he hopes that the Principia will show ways for believing in God. And it is also very well accepted for various reasons, which I will come to now. So, on one hand, you had Newtonian mechanics, which was seen to be very successful. On the other hand, Newtonian mechanics was dependent on an idea of absolute space. So, because this Newtonian mechanics was successful, people accepted the existence of absolute space. In spite of the fact there are two very important criticisms against it by Leibniz and Huygens. And Leibniz's argument was very simple, just like the arguments of the relationists. He said there cannot be something called absolute space. There is nothing called space because it's a relation between objects. And if there are no objects, there is no space. And there is no idea of an absolute space. But remember that during the early 18th century, after this was seen, Newton's comments on his absolute space and his comments as hoping that the Principia will show ways of believing in God, was seen as a divinization of space, in some sense that you bring science and God together. And in fact, it was one of the very important reasons why it was accepted with such strong support in that time. It was hailed as one of the most important achievements in England, and it's the idea spread to Europe, it spread to the US. The philosophers picked this up as a very important point. And basically, it was, at least in Britain, one of the very important reasons for its acceptance was that there was a belief that the scholastic view, which is you look at texts and try and show that God exists or not and so on, was actually superseded now by a scientific view, that one could use science to prove in some sense the existence of God. And that led to enormous acceptance both in England and elsewhere. again, for Newton, if you look at Euler at the same time period, there were a lot of people who were very uncomfortable with the idea of absolute space. Mainly because it is not verifiable. You couldn't detect it. Whatever you said, you could say this was the way it is, but you couldn't detect it. In fact, Euler spent 30 years of his life trying to prove the logical necessity that it is logically necessary that you should have an absolute space. He failed, but in the end of his life, he believed that there is something called absolute space because of its importance to the first law of motion, law of inertia. He believed with Leibniz that there are only objects, there's nothing called space. And then he spent some time trying to patch Leibniz and Newton together. One says there is absolute space, one says there's no absolute space. He'll try to patch them together. But after communication with Euler, he convinced by Euler's arguments or whatever, he accepted the necessity of absolute space. And he went about trying to demonstrate, give a proof that there is absolute space. And it's a very interesting proof. And it's based on the distinction between the left and the right. So what he said, he had what he called arguments, 4 metaphysical argument and 1 argument from Euclidean geometry. Basically what he said was this: if you take a left hand, it can never be the right hand. In other words, if you have a body and you don't have wrists and somebody gives you a hand, it will only fit into one of your hands. If I don't have this wrist and somebody gives me this hand, it won't fit into this hand. So his argument was very simple. He said there is nothing to distinguish the left and right hands internally. In other words, the relationship between its parts are the same. Both hands are identical because the relationship of all its parts are the same. But still, there is a fundamental difference between the left and the right hand. Why should that be? And Kant's argument, very simply, was just this: that it is different because with reference to something outside, this is left and this is right, or this is left and this is right. In other words, if I just give you the left and right hand, wrist or whatever, there is no structural difference between the two. But because I cannot put my left wrist over my right hand, etc., the basic argument, his argument was that this shows that there is something else outside this with respect to which this is left and this is right, and they cannot be made in one into each other. And that thing to which both of them are related to, he called it the absolute space. So his argument was very simple, that absolute space has to be there, and it is shown by this inability to transmute the right and the left. And remember that for Kant, as is well known, there's a very important, his epistemology, his philosophy was very central to his views, which is that if you look at something, what you understand by looking at something is not entirely in what you see. Part of it is contributed by the way we look at it. Part of it is contributed by that object. So when I look at something, some mechanism in my mind contributes to what I see. And this was his famous argument against for the existence of causality. When you ask the question, why should there be cause and effect? His argument was very simple. We are so wired that you only look at the world in terms of causality. When something falls, you ask, why does it fall? Not because you're analytical, not because you hold a philosophical position, but that's the way you think. That's the way you see the world. And this is largely in some sense right, because when I see something, I am seeing it from what I contribute to what I see, the object contributes something to I see. So this was then, from this view, he comes up with this central view of space. And again, this was a very profound difference from the way space had been understood till then, which was that space is not an object. Space is not an object like chairs and tables. It is the condition of experience. It is what he calls a pure intuition. It's not an empirical notion. You don't ask, what is space? How far does space go? What is it? How can I have any kind of sensorial, etc., about it? His simple point was that the moment I talk about an object, I'm already talking about space. That is, without the pure intuition of space in me, I cannot recognize objects, I cannot see objects. And again, he had another very interesting argument that you cannot think of a world without space, but you can think of a world without objects. For him, in the mind, it is possible to abstract away, remove away all objects, but you cannot imagine no space. It's actually a very interesting thought experiment to do, to see whether we can really imagine no space. Just like you would imagine that this chair and table are not there in this room. Just like I could imagine this room is empty. In the same way, can I imagine, this is Kant's argument, that I cannot imagine there being no space. So with this arguments, he thought he had proved the existence of absolute space. And he should also remember that he thought there's only one space. Space is not like many chairs and the chair, etc. He thought there's only one space, and to him, Euclidean space was the model of all space that there was. This was very influential for many years, and Kant's view on this was especially influential in philosophy and psychology. But there was one simple argument against it, and I think Helmholtz was the one who argued it first, who said Kant has to be wrong for the simple reason that there are many spaces. There is not just one space. And he said that there are, and that is the beginning of non-Euclidean geometries. He said because there are non-Euclidean geometries, it means Kant is wrong. And in fact, later arguments show why the left-right is also not completely correct. Because it is a property of certain spaces that the left-right cannot be put into a one-to-one mapping. If and our space, the space that we see now, has such a property. And you can construct spaces like well-known Mobius strip, which is a piece of strip. Instead of making it a cylinder, you twist it and stick the glue. And you take a right hand and take it around. The right and the left are not distinguishable. And then, of course, mathematicians introduce the idea of orientable space, non-orientable space, etc. So basically, the point was that Kant's view was very much dependent on the fact that it is a Euclidean. What is a Euclidean? A flat space like this, three-dimensional flat. In some sense, you can imagine what a flat means as against curve. So that was one of the reasons to argue that Kant was wrong and that his whole proof that there is absolute space false. In the meantime, we should remember that physics, mechanics had progressed very well. And people like Lagrange, Laplace and Poisson worked with a lot of physics, developed a lot of physics, never bothered about absolute space. There is a very paradoxical situation that the idea of absolute space was a concept underlying Newtonian mechanics, but nobody bothered about it. And that is true of physics even today. It was until 1885 that the whole idea of absolute space was critiqued and demolished by Lang, he eliminates the idea of absolute space by introducing the notion of inertial system. And basically, I don't want to go into it, but the point is that you can remove this idea of what Newton called absolute space by constructing various frames of reference which have some properties. Okay. So at this time, there was two things that are very clear. One, space was no longer accepted as absolute, and space was no longer accepted as Euclidean. What is parallel with this, and which contributed enormously to the new ideas of space, was the development of non-Euclidean geometry. And it arises from very simple, and I'll very briefly mention it because it's a very interesting story about Euclidean geometry. In Euclidean had 5 postulates, 5 axioms by which you construct geometry. And there was one axiom which said, you have a line and you have a point, you can draw only one parallel to it. Which we have heard in school, that 2 parallel lines do not meet. Which essentially, So for years, for centuries, people tried to show that the 5th postulate was redundant. It could be derived on the basis of the others. And for centuries, it was not possible to do that. So as a response to it, in trying to work out to see if you could construct an axiom without the 5th postulate, new geometries were created, and these actually gave rise to non-Euclidean geometry. And as an aside, one very interesting impact of non-Euclidean geometry, as some commentators have said, its impact on cubism. And it has a very interesting story, so I'll just tell you very quickly that the reaction of the Cubist painters against Euclidean space and perspectival art really catalyzed, the development of this really catalyzed their movement. And according to certain art historians, that the publication of Poisson's book, Science and Hypothesis, was very influential. It showed them how to visualize space other than its flatness. It showed them how they could look at space entirely differently. And for Picasso, it seems the twofold things that are most important to him were that space was curved and it was near. And it's a very interesting idea. And they had a mathematician, Maurice Princet, who taught them the new developments in 4-dimension. And there is a comment by one of the commentators at that time who said that people who didn't like Cubism resorted to insulting Cubism by adding the epithet mathematician to people like Picasso and others. So the final step in this story, which I will conclude very soon, is to look at the way in which space is understood now. As you would have noticed, I have generally tried to avoid the use of the word time because that opens up, that's another talk altogether. So the final development in this from modern science was through relativity. And relativity, theory of relativity, both special and general relativity, reformulated the entire ideas of space so far. So rather than talking about relativity, I'll just summarize 2 or 3 points about their implications to space. The first thing is that absolute space is completely rejected in the special theory, rejects the existence of ether. There is no concept of ether and absolute space. And because of the constancy of the speed of light, which goes against what you would see as a common sense thing, if two things are approaching each other with some speed, the relative speed should be the addition of them. But Einstein's postulate was that if light, there is no speed greater than the speed of light, that led to his formulation of the space-time fabric, which is a 4-dimensional space-time, which is a real significant jump from the way you had understood space as 3-dimensional till then. So which means that in the theory of relativity, in terms of our previous arguments, what is important to note here is that there is a commitment to the existence of space. The character of space may be different. It is called Minkowskian instead of Euclidean. Euclidean is flat, Minkowskian is slightly different. So there is an existence, there is a commitment to say that there is something called Minkowskian space, and that that events happen in that space. So we have, while Einstein rejected the absolute space, the formulation of special theory of relativity makes what we call, as I said, an ontological commitment to Minkowskian space and the notion of intervals rather than distance. The idea of distance between two things is called the intervals between two events in this special theory of relativity. And finally, the general theory of relativity, the most significant aspect, again with relation to space, is that the general theory of relativity geometrizes space. And this has a very, maybe if some questions come, we can talk about it. Since the general theory of relativity was concerned with gravity, and as you may have read in many accounts, that the masses in this space, if you have a heavy mass in space, it curves space near it. Essentially what the implications of general theory of relativity is, space-time is curved. It is not like this, what we mean by flat. It is in some sense curved. And that there is a seemingly a causal interaction between mass and space. That somehow heavy masses put here seem to imply a curvature of space around it. That can also be clarified in more detail later on. But here, I think the basic point we have to remember is that even in this space, there's a commitment to what is called a Riemannian space. So even in these formulations, which have we started off with some kind of idea of Aristotle in the Western tradition, and you end up with actually a very Platonic idea of space, which is the geometrization of gravity as an integral part of what you call as a general theory of relativity. Gravity, which is not seen as a force, ends up being the shape of space-time, as somebody calls it. So this has been a very quick review of at least the last modern developments in science, in physics vis-a-vis space. But we have to remember in much of this, we have not talked about very central issues of the experience of space, which is the phenomenological experience of space, the way in which we think as if space is around us. And I think that, for example, claustrophobia or agoraphobia, in some sense gives you a phenomenological response to space. We react as if and people who have claustrophobia react violently when they think the space between them, there is no open space around them, right? Now, again, you can answer this with the relationist argument by saying, it's just the distance between object, them, etc., etc. But this is a dimension of space which the modern developments cannot incorporate, but which has been central to much of the expressions of space in art and architecture and even in music. And I think it is, if you ask at the end of it all, if you ask me, does space exist? I can only point out that most of the great thinkers who wrote about space and talked about space were very confused about it. And as we see in this historical overview, that many times they were very wrong about it. And obviously the relativity view of space is not the last word, but I think if there is anything which says that whether space exists, it has to be a phenomenological thing, which is our experiential mode towards relating to space. Thank you.